Hello.
Hello. How are you?
Good. Good.
Hello.
Thank you for coming. We got a lot of people on Zoom, more
Good.
than I expected, and we got a couple people in person as well.
Okay, great.
How's your day going?
Very well. Thank you.
That's good. Do
I
need
turned
to
it
get-
off because we're jumping around.
Are you able to share your screen, or do you need to do that?
Let me see if I can. Nope, I cannot. So you can make me a co-host or just, there are lots of ways to go about it.
Okay, you should be able to.
Okay, perfect. Great.
Cool. We're excited. We're ready when you are.
Okay, great. Shall I just go?
Yep, sure.
Okay, sure. Okay. My name is Peggy Mason. I'm a professor of neurobiology at the University of Chicago. And Chayton has asked me to come talk to you. I'm afraid that the group that Chayton runs, I think, is more focused on things that I don't know much about, such as machine learning and more computational aspects of neuroscience. So I'm not going to talk about that. I thought that I would talk about what I usually speak about and just attach it a little bit to some cautionary ideas about viewing the brain as a calculator, as a computer. And so what I'm going to tell you about is work that I've been doing for now a dozen years or so on helping in rats and how, in at least in this context, 1 + 1 does not equal 2, or sometimes it equals 2, but oftentimes not so much. And so this started with this individual right here, Imbal Benami Bartal, who as a graduate student came into my lab, and she was asking the question, do rats act out of empathy? So I thought that was a really interesting question. The question boiling down to, are we empathic and do we help others because we went to Sunday school, because we were taught to do that? Or is it possible that this is something that is biological, that's something that we do basically because we're good mammals? And so the way that you can address this type of question is that you can ask whether another mammal that doesn't have our language skills also does whatever it is you're interested in this case, empathic helping. And so we just asked the question of whether a rat would help another rat. And the problem that we gave the rats was that one of the rats was trapped. And so here shows you that the situation, the arena is about 1.5 feet cubed. And in the middle of this, arena, there's what we call a restrainer, which is just an acrylic tube that has a door on one end. And this door can only be opened from the outside. So here you see an actual photograph. Here's the rat that's trapped. And you can see that this free rat and the trapped rat could interact. There's lots of holes in the restrainer. The restrainer is also big enough that this trapped rat can turn around, do other things. So the trapped rat is trapped, and we know we've actually done the experiment to ask Mr. Trapped Rat, would you like to not be there? And the answer is yes, Mr. Trapped Rat does not want to be there. And I'll show you those data in a minute. But it's not overwhelmingly distressful. He's not freaked out with distress. Because it's not a tight squeeze. He's in no pain at all. There's no discomfort. He'd just rather not be there. Okay, so, and then what happens is we put this free rat with the trapped rat day after day for 40 minutes at a time. And we just ask the question is, are you going to do anything about it? And it turns out that the free rat, after a few days, does open the door. And you could argue that's a little bit mostly by accident, probably by accident. But then the next day, having figured out where the door is and how to get there, he does it again at much more quickly. So the latency goes way down. And by day 12, they just go in and they open the door. So here's a picture of how this looks. So this first day, this is sped up by a lot. And you can see the trapped rat is trapped. The free rat keeps on going into the center of the arena, which is a big deal because rats don't really like to be in the center of an arena or away from an edge. The center of a field or an arena is where the hawk gets them. So they're not happy about that. So this is now day 5. And the 5th time this free rat's been there. And what you're going to see in a minute is he's going to open the door. And he's really surprised at what happens when he opens the door, which is that the door makes a big sound. And both of the rats are going to freeze. It's not a glitch in the video. Okay, so there you see the freeze. They freeze for a couple seconds. And what that tells you is that was an unexpected event. Okay. The other thing that you see is that the free rat follows the trapped rat. It is always in this direction. This event appears to be more meaningful for the free rat than for the trapped rat. Okay, so now we're on the last day, day 12, 7 days later. And now the free rat goes in there, runs around a couple times to make sure that it's the same gig as yesterday and the day before and the day before. And then he's going to go ahead and open the door. And what you see is that there's absolutely no freezing. And so what that tells you is that the door, his action to open the door produced an effect that was completely expected. He knew that the door was going to make this sound. Both of them knew it. So he's doing an intentional act by opening the door. Now, another way to look at this, and this is now 24 rats. Each row is a rat. Each column is a day. We test the animals for 12 days. And what I've just done here is to code, if the rat opens once and only once, it's yellow. Or actually, if that on the first day of opening, it is yellow. If the rat opened 12 days in a row, it would be red. And you can see that there were no rats that opened 12 days in a row, but a bunch that opened 11 days in a row that opened for the first time on the second day. And these guys get close enough to red to look red to our visual system. But the more important thing that you see here is that the rats basically convert from not opening to opening. Once they open once, the chance that they'll open again across hundreds of rats is around 90%. Once they open twice, it goes up to about 95. And by the time that they've opened 3 times in a row, it's close to asymptoting already to 100%. So it's around 98, 99%. And so what you see is that this is something that they didn't do, and then they do it. And when an animal, a human, a rat, does something time after time, and what I'm not showing this here is that they're doing it faster and faster, then it would suggest that this is doing something positive for them. There's something about this experience that makes them want to do it again. Now, what we wanted to do was to put this into some perspective. How big a deal is it that they actually open the door for this trapped rat? And so we wanted to see what's the worst they could do and what's the best they could do. And to get the worst, what's the floor is if it's just a restrainer. There's just an acrylic tube. Are they interested in opening the door? No rat involved. That's the floor. And the ceiling, the best that they can do is if they're opening for themselves. So in that case, we have the same acrylic tube, and all we do is we turn the door around. So now it's facing the trapped rat. The trapped rat can decide to open the door and get himself out or not. And this is what happens. So let's look at the empty restrainer first in blue. On the left is the median latency, and 40 minutes is our cutoff. After 40 minutes, everybody goes home, and the median latency is the cutoff. So in other words, they never open. And then the percent that open for the empty restrainer is 0 until on the 12th day of testing, it turns out one rat opened. Now, we were interested in that because there's a formal possibility that one rat had just such a great experience opening for this empty restrainer that he would do it again. So maybe this is a weird rat. Maybe opening for a restrainer is rewarding. And so we tested all of the rats, all of these 8 rats, with another day on the 13th day. And on that 13th day, none of the rats opened, not the rat that had opened on the 12th day, and none of the other rats either. So that's 13 times 8, which is 104. And out of 104 rat day opportunities, there was one opening. So in other words, rats do not open for an empty restrainer. That is just simply not something that is rewarding. So the self-release, when we turn the door around and the trapped rat is now letting himself out, is shown in the black squares. And what you see is on the first day, most of the rats, I think this was 9 out of 16, opened with a median latency just under 20 minutes. By day 12, 15 out of 16 were opening essentially at 0. You'd put them in, and as you're walking away, they would open the door. They're out of there. They know how to do it. They're out of there. They don't want to be there. So there's a couple interesting things. First of all, they don't want to be there. Okay, I told you I would show you those data, and these are those data. And the second thing that's interesting here is that there is one rat that tolerated it. So again, this is not torture. So, this one rat is weird and is perfectly fine to just be stuck in there. Okay, so in this landscape between not opening the door for an empty restrainer and opening it really quickly for the self, where does helping another who is trapped sit? Where is it in this landscape? And this is the answer. So here are 24 rats, and what you see is that they basically don't open, and then they open. So they convert from not opening to opening. And you could make the argument, and I would make the argument, that the reason that they convert or let me put it a different way, the reason they're not opening on these first 3 days is because they don't know how to. This is not the easiest thing in the world for a rat to do. So they don't know how to do that. But they do, but once they figure it out, then they're going to do it really quickly and very consistently. Now, about 75% of the rats end up opening and about 25% of them end up not opening, and why they don't open is a different story. It's not what I'm going to concentrate on today, but I can talk about that in the question period if you're interested. Okay, so one of the things that that we saw, so what this shows you is that once they've opened, it's such a positive experience, they want to do it again. Now, one of the things that we did was at the end of an experiment, we usually do a pilot. And so the pilot that we often did was on the 13th day, we would give them an empty restrainer. And now these animals, these rats that had opened repetitively, if we give them an open restrainer consistently, they open that open restrainer. Okay. So what does that tell you? They won't do it if you can't train them. They will not start to open if at first given an open restrainer. They'll only do it after they've opened for a rat. So what that tells you is that opening has become a habit. It has become a habit because opening for a trapped rat is such a positive experience that they want to do it again. And now that action has become outcome independent. That's the neurobiological definition of a habit. I hope that's clear. If there are any questions on that, I can go over that now. Any questions? Okay. So we knew that they could form a habit by day 12. I'm sorry, by day 13. And so what we asked actually, how long does it take to form a habit? And we decided to do an experiment where we would test them after either 2 days in a row of opening or 4 days in a row of opening. And here are the data. So in black is the animals that opened twice in a row for a rat. And then thereafter, they were tested with an empty restrainer, and you can see that they continued to open at basically zero, very, very short latency for the rest of the time that they were tested. And the same is true for these animals that open 4 days in a row. When they're tested with an empty restrainer, they also opened. So this is habit forming very rapidly. Another clue to the fact that this is very rewarding. You don't form habits for things you don't care about. You form habits for things you really like, that are very positive or experienced in a very positive way. So we wanted to kind of put this into a calibrated landscape. And so what we decided to do is compare it to chocolate chips. So what rats usually eat is chow. It's all carbohydrates. There's no sugar. It's not particularly palatable. And so these are not food deprived animals. These are just animals that get this extra highly palatable, energy dense food on the side. And they know they like the chips. So what we did was we trained them. We said, okay, we knew already that it only took 2 days in a row to form a habit for the rats. So we skipped the 4-day condition. So we said, well, once a rat opens twice in a row for chocolate chips, we're going to test that rat with an empty restrainer. And here is one particularly interesting rat. So this was a rat that opened for chips on days 1 and 2. And then we tested this rat with empty restrainer for the next 10 days, never opened. Okay, so never opened for an empty restrainer. Now on day 13, what we did was we gave him a trapped rat instead of an empty restrainer. He already knew how to open the door because he'd done it on days 1 and 2. He just chose not to do it on these intervening 10 days. So he opened the door for the rat. And then what we did was now we give him an empty restrainer again. And lo and behold, he opens for the empty restrainer. So what that tells you is that opening for a trapped rat is more habit forming than opening to access a highly palatable food. That's, that's a powerful, these are powerful indications that opening is an experience that feels good, that an experience that makes you want to do it again. Okay. And then when we looked at all of the animals that we tested with chocolate chips, compared to the animals that we tested with rats, what was striking was that 21 of 24 rats tested with a trapped rat opened at least twice in a row. But so that's, I don't know, that's around 80% or something. And then, but only half of them opened twice in a row for chocolate chips. So first of all, they're getting into the game less because it's just not as big a deal when they are not as rewarded by opening for chocolate chips as they are for opening for a trapped rat. And then when you look at how often did they open for an empty restrainer after that time, what you see is that they always open for an empty restrainer if they had been if they'd opened twice for a trapped rat, but they did not always open for an empty restrainer if they had been if they had opened twice for for access to chocolate. So chocolate is less habit forming any way you cut it than is opening for a trapped rat. And what this tells you is that helping this experience that they have of opening the door and letting the trapped rat out is positive. And we would argue that it's the same thing that has been hypothesized to happen in humans with donations, which is it's the warm glow of helping. Helping is reinforcing, it feels good. And this on the right, I show vegetable oil, and this is supposed to be water. We know that the rats will actually pay a certain amount of certain price to help. And this comes from an unpublished study where we had rats that had been tested in the normal routine in the arena, and then we made a different setup where the free rat was here and the trapped rat was in a different area, and connecting the two was a narrow corridor, which we had, and we made that into a pool. And in that pool, we originally put vegetable oil. And when it was vegetable oil, none of the rats would walk over and access the trapped rat and open the door for him. The moment we changed that pool from oil to water, the rats went screaming across and opened the door. So what that tells you is that the price that they're willing to pay is walking through water, but they're not willing to pay walking through oil. They really don't like oil. They don't like touching oil. So the exact price is not so important as the fact that they will pay a price to do this. This is by definition valuable to them. Okay. So now what I want to switch to is our work on the bystander effect. And this came from the bystander effect was originally conceived of by Bibb Latane and John Darley in the late 60s. And this book from 1970 is a very narrow volume that you can read in an afternoon. It's written really well. It's written not in science speak, but it's written in actual prose. So it's a fun book to read. And there were a couple of crimes, in fact, that pushed Latane and Darley to examine this this phenomenon. And one of them has stood the test of time, even though it's 100% apocryphal. Okay, this didn't occur the way that they thought it had occurred, but it sort of doesn't matter in the big scheme of things, because for them, it was the motivation to then uncover a very psychologically robust effect, which is called the bystander effect. So the story went that Catherine Genovese was killed, raped and killed as people on the street looked on, and they didn't care. So whereas maybe if one of them had been there, one of them would have called the police, but because there was a crowd, there's this diminution or dilution of responsibility, and no one called. And so the basic bystander effect is that an individual is more likely to help when they're alone than when they're in a group. That's the bystander effect. And that you'll find that in every psychology textbook. Now, the way that this has been studied in psychology forever, since Latanya and Darley, is by having confederates. So I'll give you an example. So a person comes into a room and they think that the experiment is about these two were at Columbia. So they think the experiment's about their adjustment to New York City in their first days of college. And so they're taking a questionnaire, and as they're sitting there, some smoke starts to come in from the air return. And if they're alone in there, it was 80% of them would put down their pencil, get up from their chair, leave the room, and tell somebody there's smoke coming in the room. In contrast, if that same situation, but now there are two people that are part of the investigative staff, two other college students who are sitting there and ignoring the smoke, it goes down from 80% to 13%. So 13% of them actually get up and report the smoke. So why don't they? Because of the others are altering, modifying their behavior. They're being modified by their perceptions of these other individuals. So, so we looked at this. This experiment was led by John Havlick, who at that time was an undergraduate in my lab, and now is at he's probably, yeah, I think he graduates this year from Yale Medical School. And one of our medical students, and then some undergraduates. And so what we started with was, will rats have the same, can we see the bystander effect in rats? And so what we did was we did two different experiments. In this, in the duos, there's one rat that can help, and then there's one rat that's drugged. So he's our Confederate rat. He's the rat that can't help. And in the trios, we had 3 rats, only one of whom could help. The other 2 were drugged. Okay, so what did we see? So what we saw is shown here, and let me introduce the way we show these data. So on the x-axis is the total number of openings. We're testing for 12 days, and on the y-axis is the number of consecutive openings. So if they are perfect openers, they will open 12 times, which means 11 times consecutively. So this dotted line shows you that wherever they start, they're perfectly reinforced. They never miss a day. Okay. And that tells you, again, this reinforcement is a metric of how much they enjoyed it, if you will. So what you can see is that these are the control rats. These are rats that are tested alone. They're solo, and they on average started opening on, say, day 5, or this is median, but okay, so the median first day of opening was they opened for a total of 8 times, so that would be on day 4, excuse me. And they, once they opened once, they opened every day thereafter. Okay, so they're sitting on this dotted line. Now, if there was one Confederate, what we saw was that they didn't open until after day 6. And if there's 2 Confederates, they didn't open till, what is that? That's 4, so day 8, very, very late. And in both situations, once they opened, it was sort of a crapshoot whether they would open again. So they're sitting pretty far away from this dotted line. They don't take every opportunity to do this again. So this is a recapitulation of the bystander effect in rats. So one of the things I like about this is there's a lot of hand wringing about when people talk about the bystander effect, they talk very lofty, as though people are choosing to be uncaring of each other, and that this is a sign of our society going to the dogs, or a sign of people not caring. And I think that these results show you that is not the case at all. This is simply biology. This is simply when the idea being that when this individual finally opens on day 6 or 7, the other rat or the other 2 rats don't care. They get no reinforcement from those other rats. And so their perception of the others, the bystanders' non-caring attitude, colors their own perception of their activity. They're better off if there's without a bystander than with a bystander who doesn't care about what they just did. Okay. So we wanted to then ask the question, well, what happens if you have 3 rats or 2 or 3 rats, all of whom can help, and we don't have Confederates? So these are naive bystanders. And this is the picture with, there are 2 rats that can help. Neither of them is drugged. And here's the trios where 3 rats, they all can help. So what happened was this. Well, first of all, with the trios, we could only test them for 6 days. After 6 days, they were all opening instantaneously. And so to continue to test them from days 7 to 12 would have been, there was nothing more to learn. They were opening. So we only tested them for 6 days. And so this is the total number of openings that they could have was 6. And the total number of consecutive openings they could have was 5. And for the trios, they're pretty close. The median is pretty close. There's only 1 rat that didn't open every day. 1 trio that didn't open every day. I think 1 trio didn't open on the first day. And then these duos, they're also sitting on the perfectly reinforced line. And I'm sorry, here are the controls. Here are the duos. Here are the trios. The trios were perfect. The duos, they start opening on day 2. The median of day 2. These guys, median of day 1. And these guys tested alone, the median day was 3.5. So what this tells you is that it's incredibly reinforcing when there are bystanders. Now, one thing that you could say is, well, there are more rats, so of course there's going to be more helping. And in fact, and that's absolutely true. So what we did was we did a simulation where we took 24 control rats that had been tested solo, and we put them into groups of 3 or groups of 2. So we simulated these rats that were tested alone but we in silica put them into groups. And we said, how often does one of the rats, it doesn't matter which one, any of them, open in these in silica groups? And what you can see is, so these are the shuffled trios, and these are the shuffled duos, and these are the solid is the experimental duos and trios. And so what you can see is that the only difference is on day one. On day one, the experimental duos and trios are much more likely to open than the shuffled ones. And this is where the effect is. So the first effect is that they're emboldened to get into the center of the arena. They're more active and they're more likely to open for the first time. The reinforcement is simply that they're incredibly reinforced. Now, to look at the reinforcement, I'll show you those data in a moment, but first I want to put this into context. It seems as though this really contradicts the psychology canon of the bystander effect, and it doesn't. It's just sort of it's a different question because there are no Confederates here, and in fact there is a literature in sociology started by a sociologist at Ohio State, Quintarelli, and he went to study the 1964 Alaskan earthquake, which was a very big one, 7.9, 8 point something. It was a huge earthquake. And he had people on the ground within 36 hours. And his question was, here's a situation where there's no law, there's no order, there's no regulation, there's no government, because you have a big natural disaster. So you could think that everyone's going to go and take great advantage of the situation and act very selfishly. Well, in fact, the opposite happened. And he sees this over and over again, that in fact, people came together and at great risk to themselves would go out of their way to help others. I was in the 1989 earthquake in San Francisco, which was a big one, 7.3, I think. And it was a disaster. And it was the same thing. And I can tell you that the experience of that, and if any of you have been in a any kind of a disaster situation, you're just filled with the milk of human kindness. You just want to go help other people. People crawl there. There was an expressway that just pancaked, and people crawled between the two roadways without knowing that there wasn't going to be another aftershock, because there were a lot of aftershocks, and without knowing that it wasn't going to collapse more. They crawled in there to look for survivors. So people, so what we see here has confirmation in the sociology world. And then more recently, Mark Levine, who's in the psychology department, did a very clever experiment where he looked at just CCTV footage from Copenhagen, from the Netherlands, from South Africa, and from 3 different countries, but everything was incredibly consistent. So what he looked at were these hostile conflicts that were caught out in the street. And there were on average, I don't know, 14 bystanders. And the question is, how often did the bystanders intervene in this? And the answer was over 90%. So there's just no way that you can get to a place of that is not consistent with the psychology notion of being less likely to help in a group than as an individual. This is consistent with the sociology version of naive bystanders positively affecting the likelihood of helping. Okay, so what we found with the rats, it has support in work from humans. So the final issue that I want to just touch on is with these trios. I told you that after day 6, there was no point in testing them more. They were just opening, so we weren't going to learn anything more. So what I decided to do with those trios was after day 6, from day 7 through 12, we tested them individually. Okay. Now I need to tell you one more thing, which is when they were tested as a trio, for 7 out of the 8 trios, it was the same rat who opened every day. Now, would the other 2 rats have opened if that rat hadn't opened? Well, we will never know. We don't know. We didn't re-trap the trapped rat. So all we know is that there was 1 rat that beat the other 2 to it. Okay. So what we had was 8 rats that were the openers and 16 rats that were not openers. And so what we could say then is this, and that's in the group experience. Now, when they're tested alone, what do? And this is what happened to the rats that were not opening. So so here in black are control rats. These are control rats, and we looked at all the control rats that didn't open on day 6. How many of them opened on day 7? Not many. I think that is 1 or 2 rats. But most of the rats that did not open on day 6 when tested in a trio did open on day 7. Moreover, the latency that they opened at was based on the latency that the opener in that animal's trio had opened at. So what we have here is an example of observational learning. Okay, so now what about the animals that did open? The 8 animals that did open, well, it was actually 7 because there was one group where it was an equal opportunity opening. So these animals that did open on day 7, only 3 of them opened on I'm sorry, the 7 animals that opened on day 6, only 3 of them opened on day 7. So now they're quitting. Whereas if you look at control animals, if they opened on day 6, every one of 29 opened on day 7. Moreover, on days 8 through 12, how many openings were there in the control group? There are 5 openings. There was no variation, but in these rats that had used to be part of a group, used to open with 2 witnesses, and now they're being tested alone, they open much less frequently. They skip days. So what this tells you is that they love an audience. One way to put it is that they love an audience. Another way to think about it is that their evaluation of the worth of opening is very fragile, and it's so fragile that it's the loss of the audience has now undermined the value that they originally put onto it. So this brings us to motivational crowding, which is an idea that has been around for about 50 years, I'd say. And so the basic idea of motivational crowding is that if you let's say you pay somebody, you pay Susie to share her toys with her brother. Every time you share your toy with your brother, I'm going to pay you a nickel. And now, and you don't pay Jane. Jane just, she shares her toy or she doesn't. And now you stop paying Susie, and what you'll see is that Susie will no longer share her toy, and Jane will continue to share her toy. So the idea is that you need that internal reward but if you provide an external reward, that will undermine the internal one. And so people have worried about this. Economists worry about this a lot. And public health people are worried about it because, for example, should you pay people to give blood? Should you pay people to take the COVID vaccine? And this is an applicable problem. And so I just want to show you that this is a there are data that support this being a problem in humans. This is a study in Denmark. And what's interesting here is that this is a weird effect, which is sexually dimorphic. So women, if they are not paid, they donate at a rate of 52%. If they're paid for their participation, they donate at 30%. And if they are told that a donation is going to be given to charity, they're back up to 53%. So this is again an example of motivational crowding. And so essentially what the conclusion is that the introduction of monetary payments may reduce the intrinsic motivation to behave for another's benefit. And what we have is an example of that in the rats. So I'm going to end there. I'm going to tell you the two, hopefully I convince you of two things. One is that helping feels really good. It creates this powerful internal experience that is akin to the human warm glow of helping. And you know, there's a downside to that. There's a downside to everything, in my opinion. So the downside of that is that it feels so good that the helper can crave that feeling, regardless of whether what they're doing actually is helping another individual. So we can talk about that. That's a little more on the philosophical side. And the conclusion number two is that the internal reward occasioned by helping is fragile. It can be devalued by others' opinions or by extrinsic rewards. And so that's something to think about as we navigate and try to understand how do we make the world a kinder place, and how are we really doing good when we incentivize doing good? So I will leave you with those questions. This has been the work of a huge number of people, including mostly undergraduates, and I'm such as yourselves. So, and with that, I'm very happy to take questions.
Thank you very much. Also, I realized I forgot to introduce you. I'm so sorry.
That's okay.
Because I introduced you in person, but I forgot that there's Zoom. So to those who missed it, this is Dr. Peggy Mason from the University of Chicago, professor of neuroscience, and I'm sorry I did that so late. Yeah, that was super interesting. Do we have any questions in the room? If not, we have some on Zoom. Okay. Sure, let me pull. Oh, we have one question. Jana is asking, is that a cat behind you?
What's the question? Is that a cat?
Sure.
Yes, that's a
Is that
cat.
a cat?
That's Minnie. Yes, but she's been a very good girl and hasn't decided to go in and out.
Okay. Oh yeah, we got another question.
Have you tried? Hi. Have you tried like putting like a chocolate chip and a rat both in like those cages and seeing like if helper rat can choose one? Do they choose to ward themselves or flee the other rat?
So we did that experiment in our first paper. We did that experiment, but we didn't do it Sophie's Choice. So they could do both, and they did do both, and they did it at equal latency. So they would one day they would start opening for the chocolate, and another day they would start opening for the trapped rat. They didn't, they're basically the message of that experiment was that they were on a par. I will say that one of the most extraordinary finding in that experiment was we did two conditions. One where it was chocolate and an empty restrainer, or chocolate and a trapped rat. When it was chocolate and an empty restrainer, the rats ate all 5 of the chips, 4.8 out of the 5 chips. When it was a rat and chocolate, they only ate 3.5. So they left 1.5 for the other guy, which I thought was quite remarkable. Something probably my sister-in-law would not do.
Thank you.
Okay, we have a question from Zoom, and it is, how do you see the knowledge from neurobiology research being used in the future?
I don't know.
Big question.
It's gonna be up to you. You are the future. And so my dream is that neurobiology is another gets a seat at the table. I think right now things get discussed economically, politically, sociologically, maybe if you're lucky, psychologically, but I don't think people think about the biology of the situation. And I think that, for example, with the bystander stuff, this is a powerful model. It can tell us a lot about where individuals are more and less likely to help. How can we, writ large, increase helping? And I don't think it's through teaching people. I mean, I think this idea that you can explicitly teach people to be empathic is not the right way. And I don't think that that's where our data would suggest that we can gain the best advantage. But what I hope is that there are more and more people with some interest in and basic knowledge of neurobiology that go into all walks of life, go into politics and architecture and everything, so that yeah, this is what I was afraid of. Okay, Minnie. And that's really the only way that the future will change. So right now, Congress could care less about neurobiology, right? So you're the ones who have to change that.
I guess sort of following up on that, we had some other questions regarding sort of what neurobiology might look like with new technologies like Neuralink or like invasive brain-computer interfaces, and sort of how that data might shape the future and what your thoughts might be.
So as Jeff Mogul said about my experiments, and this is so true, he said, your experiments could have been done in the 1600s, except for the acrylic. Okay, but I am retro beyond retro. I'm just not, I don't find brain machine interfaces that compelling. And the basic reason I don't find them that compelling is they're not scalable. In a world where we can't get people to, we can't even get everyone who needs insulin. I don't get it. And I'm not saying I'm right, but for me, that's not where I would put my money. That's not where I would put my interest. If you wanted to be utilitarian about it, BMI is not the way.
Okay. If anybody also would like to raise their hand in the Zoom, you can ask a question now as well.
Yeah.
Hey, I was wondering if it was if you used any fMRI on the rats or try to
Any
understand
what? Say that
if you
again.
use any fMRI on the rats, or I'm just trying to understand what the biology behind the bystander effect would be, or anything about that.
So I haven't done that. Inbal now has her own lab, and you know, sort of to be expected, she found that there's activity in incumbents when they open the door for an animal. It was a little complicated, but she found the reward signal that you would anticipate in incumbents. That's where you would expect it to be. As far as using fMRI, we haven't done it. It's sort of hard. At what point do you do it? You know, fMRI is not an instantaneous thing. It's not recording. So what period of time do you take them out, anesthetize them, stick them into the magnet, and decide that's going to give you a meaningful datum? So what the way Inbal went around this was to do CFOS, which is a sort of a dirty way of seeing who's active over a period of time. And a lot of neurons throughout the brain are active. I haven't done this work. I have not gone into the brain to try and figure out what's going on. We're still mining a lot of behavioral data, which I find is really fascinating. So that's where we're stuck at.
Okay, yeah, I wouldn't know. I was just I guess I was interested in steering the conversation in that direction.
So there's a lot of fMRI that's been done in humans with these scenarios. They're in the magnet, they read some thing, and then they and there's also been some EEG on that. And so the areas in the brain that are supposed to be involved are accumbens, which you would expect, prefrontal cortex, amygdala, and hypothalamus would be sort of the top areas. Yeah. Susie.
Hi. Sorry, thank you so much. That was amazing. That was really fascinating. I find all your work on empathy to just be incredibly interesting. I guess I come from an anthropology background, and I'm sort of interested in government policy in terms of using this kind of research and data to improve society. I suppose that could be one of the points. Like, how can we translate
absolutely.
Right, how can we translate the research and the findings into making society a better place for everyone? And just one thing that I don't think that you mentioned, but sorry if you did. I wonder how the rat's empathy would change depending on the age of the rats, and how much that would be, their empathy would be plastic based on at what age you kind of intervened and did these experiments on them. Just something I was thinking just now, so sorry if this is not very well articulated, is that one way to kind of, I guess, show a government that's doing programs for, say, children of school age to increase their empathy and their desire to help others and to think from others' point of view, is that intervening early might have a lifelong effect. So I was sort of just thinking that one way to do that would be to do the same experiments on rats, but on much younger rats at a very important developmental stage in their neural development.
So,
and yeah. and see like
so
what effect you could have that would have a long-lasting effect. Just based on that, I imagine there might be a sort of a moment that is very plastic in their development.
I probably didn't emphasize this enough, but the basic idea that rats do this tells you that the default is to help. Okay, so our mammalian default is to care about and help another in distress. What you learn is to not help. And this has been demonstrated in both chimps and children. The children piece was done by Warneken and Tomasello in a beautiful series of experiments. And basically what they show is that at around 4 years old, the kids stop helping everybody and start to help in group, preferentially over out group. Okay, so, and you might think, oh, that's terrible, horrible, horrible. We should help everybody. But the fact of the matter is, no, helping is really costly. It's resource depleting. It's resource depleting, in a cultural sense, it's resource depleting in monetary form, but in another sense, it's resource depleting emotionally. And you only have so much time, and you only have so much emotional energy, and you cannot help everybody. So it is actually evolutionarily quite advantageous to help the in-group preferentially and not help the out-group. So what we were able to show in work that I didn't present is that the in-group, out-group is a very plastic categorization. So what we learned was that if a albino rat had never met a black Cape rat, not a single one, they would not help a black Cape rat. If an albino rat had lived with one black Cape rat for 2 weeks, it would help any black Cape rat. So then we asked the question, that tells you that environment has a very profound effect, right? I can stick you, white rat, with a black Cape rat, and now you're going to be good to all the black Cape rats. I can dictate who you're going to help. And now, if that is true, then what is the role for genetics? And so what we did was we took the albino rats on the day they were born, and we put them into a black Cape litter that had been born that same day. So on P0, they get transferred from albino litter to a black Cape litter. They grow up. When they're weaned, they're housed with a black Cape rat litter mate of the same sex. And when they're adults, we asked, would you help a black Cape rat? Of course they do, because they've lived their entire lives with them. But the real question is, will they help an albino rat? And the answer is no. So what that tells you is that you have complete control over the target of helping, not whether helping occurs. Helping's going to occur by default. I mean, with humans, we have all sorts of cultural blah, blah, blah that sits on top of that and keeps people from helping for a variety of reasons. But the mammalian inheritance is to help by default. And the place where you have incredible plasticity is who's the target of that. And so the place where that, what we've learned is that just some kind of exposure, and one of the things that we're very interested in, what is it about that 2 weeks? What happens in that 2 weeks, and what are the cues that get used to say, oh, that's an okay type of rat now? But that's where I think the interventions can happen. And if you look at, this does not map perfectly onto our experiments, but it maps pretty well, which is that students from more racially diverse high schools are less bigoted, racially bigoted when they are adults outside of high school. So which is consistent with our results from the rats, that if there's exposure to a type, that type is an entity, is a biological entity that you are going to care about. Now, this is profound because one of the things that we did, I didn't talk about, is we did the bystander effect with a Confederate rat that was black cape. So there's an albino rat that's a potential helper. There's an albino rat that is trapped, and there's a black cape rat that's drugged. Okay. Now, if the albino rat had never met a black cape rat, he acted as though he was alone. He opened. But if he'd ever lived with a black cape rat, he acted as though there was a bystander sitting there, and he didn't open. So in other words, if the albino rat is going to count as biological, anyone who it has interacted with, anyone who's been exposed to. But if they don't know that type of animal, that type of rat, then that type of rat is basically a stone to them. Now that's a powerful thing. And that's where I think that our results could be incorporated to make helping a more to make helping more prevalent, so that you're willing to help a variety of different people.
Great. Thank you so much. That was
All right. Well, good luck to all of you. Convince me that I'm wrong. I hope you all convince me that I'm wrong, and there's some great use for brain machine interfaces.
yeah, I mean,
I'm always willing to be proved wrong.
no. I mean, we do lots of stuff besides that, just trying
Yeah.
to neuroscience and apply it to machine learning. So that was really fascinating.
Good.
Yeah.
All right.
All
Good
right.
luck to you all. All right. Bye.
Have a good night.